So moving to the first task, basically first task purpose is to efficiently determine the nearest parking location for users. Specifically, my part is designed to find the nearest parking spots for users based on their uh, the geographic locations. It employs an R3 data structure for efficient spatial query and includes various search methodologies to optimize performance. My part combined from total like 318 row altogether. Moreover, in this task, we are specifying uh, efficiency in spatial query. That spatial query can be like computationally expensive, specifically when dealing with the large datasets. By implementing optimized search algorithm, like for example R3 structures and best first search, uh, this task reduced the time needed to locate nearby parking spots. Nextly, in the first task, the real world applicability in urban planning and smart cities. Well, as we see, urban planners and city infrastructure managers often need to optimize like the allocation and access to parking spaces in busy areas. This task helps simulate the analyze user proximity to available parking, making it possible to identify optimal location for parking facilities. The last one is data structure and algorithm optimization practice. To practicing and doing this first task, we implementing tasks provides like valuable experience in applying advanced data structure, like as I said R3s and algorithms such as best first search in a real world context. Next page is about data overview. The description of dataset, like each dataset consists of 2D points representing parking dataset, where each line includes a unique ID for a point and its geographical coordinates and longitude and latitude. For example, as we see that slides in the parking dataset, such as ID 1 equal to 1, the X equal to 64.26 and Y equal to 144.62 precisely indicates the location of parking, with X representing longitude and Y representing latitude. Overview of algorithm that state that three methods were implemented. First one is sequential scan method. Second one is best first algorithm, and last one is best first with the divide and conquer. Sequential scan method, this approach identifies the nearest neighbor by calculating the distances from the query point to each point in dataset, selecting the one with the shortest distance. The best first algorithm The construct an R tree for the selected dataset, then apply the best first algorithm using the R tree to find the nearest neighbor for each query point. Best first with the divide and the conquer. The dataset starts by splitting the dataset into two subspaces based on either the x or y dimensions. Next, build a separate R tree for each subspace. Apply the best first algorithm within each subspace to find the nearest neighbor to find query points. Then finally, convert the nearest neighbor identified in both subspaces, selecting the one with the shortest distance as the closest point in the entire dataset. Thank you for your.
Hello everyone. Today I will presenting key part of our project. In our group, each member was assigned a specific task to ensure efficiency and focus. So my responsibility was to document and analyze the analyze the divide and conquer strategy. So which involved breaking down the data set for optimizing the searches. So let's start for providing an overview of core function we use it. So our project relied on several essential functions that were crucial at the success. So some of I will mention about including R3, best first scan, and divide and conquer, all of the which played a significant role in handling optimizing large data set. So the contract R3 function was responsible for building the R3 structure. So which is contractory function was contract R3 function was responsible for building the R3 structure, which is a key component for spatial indexing. Then we use the best first scan to efficiently locate nearest neighbors. Finally, divide and conquer. It helps us split the dataset to improve computational performance. Each this function had distinct purpose, and whether they allowed us to achieve the significantly better results compared to bring the basic approaches. Now, now I let me explain what an R3 is and why we used it. So the R3 is a data structure specially used for efficiently indexing multi-dimensional information, which is extremely useful for spatial indexing. So in our project, we use it um, we used R3. We used R to manage and search through the large sets of data point effectively. During its construction, we inserted point sequentially. When a node reached when a node reached its capacity, we handled our follow by splitting the node. They propose minimizing the overlap between nodes and kept the R3 plans, which significantly enhanced search performance. The further optimized nearest neighbor search. We employed the divide and conquer strategy. This strategy allowed us split the dataset into smaller, more manageable parts, which improved the search efficiency. So, by narrowing down search space, we significantly reduced the computational overhead. We divided the dataset into subspaces, and each spaces was pursued individually. This approach ultimately improved the efficiency of search algorithms, making it possible manage larger dataset effectively. So throughout the project, we faced the several challenges. One of the major challenge was documenting the complex processes such as handling node overflow and visualizing the artery construction. This task required the precise analysis and detailed diagrams to communicate our approach clearly. So from the challenges, we learned importance of maintaining balance in data structure like R tree to optimize the special relationship and ensure the efficient searches. Moreover, we also realized that well organized document so documentation is crucial for effective collaboration within the group and for making our group work understandable to others. So lastly, I want to compare the different methods we used in our project. Especially, we compared the efficiency of sequential scan, best first search, and divide and conquer. By analyzing the running time and computational overhead of each method, we found that advanced techniques like best first search and divide 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 and conquer conquer. So by analyzing the conquer significantly outperformed the simpler sequentially method. This improvement performance is crucial for handling large dataset efficiently and ensure that our solutions are application to real world scenarios. So thank you for your attention. I hope gives you I hope I will hand over to my next member.
Hi, my name is Thayphong Thavirin. In my group, I'm in charge of task 2, and now I will explain my task 2. For the introduction, actually I have 3 datasets, CT1, CT2, and CT3. And these datasets representing homes is stored as 2D points in text file with ID home X like a cost and Y is a size value. And my task goal is apply skyline search algorithm to identify homes that optimally balance cost and size, filtering out properties that are either too expensive or too small relative to other options. Now we come to the reasons why this task is significant actually in the real life. I have 3 reasons. The first reason is real estate decision making. It means providing potential home buyers with a systematic method for identifying the most suitable homes based on their budget and space requirements. The second reason is efficiency. By utilizing the Skyline search algorithm, the program optimizes the search process and enabling user to quickly filter through various options and focus on the most promising homes. The last reason is data-driven insights. The analysis from the Skyline search can offer insight into the market condition, helping buyers understanding which home offer the best value for their needs. Now, let's have a look on the dataset. Actually, the datasets have many rows inside the text file, and each row represents for one home with three values. The first value is ID home, the second value is the cost of that house, and the third is the size of that house. For example, if the rows have three values 1, 5, and 10, it means the cost the ID of that home is 1, and 5 is the cost of that home, like 5,000 dollars for that home, and 10 represent for the size, like 10 square meters. Okay, now let's have a look on three algorithms we use in that task. The first algorithm is sequential scan. It means evaluate each entry sequentially to check if it's dominated by any other entry or not. The second algorithm is branch and path skyline BBS algorithm. Firstly, we're gonna construct an RT for the dataset and use the BBS algorithm to find out the skyline points. The third algorithm in this task is BBS with divide and conquer. We're gonna split the dataset by either cost and size and build the artery for each subset. Apply BBS to each subspace and merge the result using 1D dominance screening. Okay, now we're gonna move into each method or each algorithm. The first method algorithm is sequential scan method. This algorithm evaluates each home in the dataset by comparing it to every other home, as I already explained before. So, by using this method on the dataset City1, my outputs have the skyline with 8 points. It means I have 8 homes in my skyline, and the time to run this method is around 2.7 to 7 seconds. Okay, now let's move to the second method, is branch and path skyline BBS algorithm. Firstly, I construct the RT, and after that we use the BBS algorithm to find out the output. My output also the same with the first method is sequential scan, but the time for the BBS algorithm just only in 0.5892 seconds. It means it's around 5 times less than the sequential scan method. And for the third method, BBS with divide conquer. In this method, we gonna divide into 2 subspace based on 1 dimension. Like we're gonna separate the X value and the Y value. It means the cost value and the size value of that home. And we apply BBS algorithm for each subspace, like the second method before. After that, we gonna combine the results from 2 subspace method to figure out the output. And my output in this method is the same, like 8 home with compared to the 2 previous. method, but the time for this task for the BBS with divide and conquer just about 0.2131 seconds. It means it is 2 times less than the BBS algorithm method before, and 10 times less than the sequential scan. Actually, when we compare the output of 3 algorithms, is it the same skyline, but the way how we figure out, how we point out the skyline is different. So let's come to the conclusion. Actually, the 3 algorithms always have the effectiveness for in each algorithm. For example, sequential scan is straightforward, but it's quite slow, especially with the large data sets. As you can see, the time to run the sequential scans is the longest one, 10 times more than the BBS with divide and conquer, and 5 times if we compare to the BBS with a single artery. For the BBS with the single artery, the effectiveness can improve efficiency by indexing points or reducing unnecessary comparison and offering the faster result. But the last algorithm is BBS with divide and conquer is the most efficient, dividing the data into subspace for parallel processing and further reducing computation time. Actually, each algorithm always have strengths and weaknesses, but inside 3 algorithms, the R3 always enhance the scalar efficiency by indexing data points and dividing the dataset into improve performance further. However, implementation complexity increase with advanced method. Thank you so much for your attention into our presentation. We have 3 members and we already work together to solve 3 tasks individually, but not really individual. We always have together to improve our result in this task. Thank you so much, and hopefully we can see in the next unit. Thank you.